G'day, it's your old mate Prezzo here, back in the shop, and what we're doing today is we're looking at how to modify the cover of this drill press so that we'll close down onto this unit. Now this is a pull gear. It's an accessory for a drill press or a small lathe, or more recently I've been told it would be useful on a bandsaw. The pull gear gives you roughly a 4-to-1 reduction in spindle speed without sacrificing torque. It's a unit that can be built in the home workshop. You would need a lathe and a milling machine, but it's not beyond the capabilities of a home shop machinist. If you're interested in building one of these, I put the 3D model and the 2D drawings on Dropbox, and there's a link in the description below, and you can download those files entirely free of charge. No catches, no hidden agenda. They're there for you to use if you want them. The drawing is in PDF format and also in the original Autodesk Inventor format. Now, if you don't own Autodesk Inventor, you can use them with Autodesk Fusion 360, which a lot of people I believe now have. You can get that software for free. There are ways of doing that, but certainly the license fee for it is not very expensive. If you own something else, like for example SolidWorks, I believe you can import Autodesk Inventor files into SolidWorks and some other CAD packages, but you can just get the 2D drawing in the PDF format. Now, as a problem with this is that there's an extra height involved with this pull gear, and I can't close the belt cover on this machine. So this video is going to be about how to modify the belt cover. Well, just as I expected, the workplace health and safety officer made me sit down and do a risk assessment and come up with a risk management plan. And I agree, it is dangerous, so I come up basically with a 1-point plan. Okay, so this is the cover on the bench now. What I need to do is to cut a hole in this end at the top. And I could just cut it across square, but I just thought that was going to look a bit ugly, so I want to be able to draw a circle on top of that. Now, the circle has to be projected down onto this curved surface. If I was to just get a divider and run that around there, then the shape that it would trace out would not be circular, because this top is not flat and it's got the contoured edge here. So, I could do it, and a divider would give you a curve that looks okay, but why do things the easy way when you can make it hopelessly complicated? So what I'm going to do is I'm going to try and generate the shape of this profile here, and I've got one of these sort of profile gauges, and I can replicate that contour . Alright, so that's a representation of my contour, and what I need to be able to do now is to generate some geometry from this and try and get that fairly accurate. So the next step is to map out that profile on paper and establish a center line and also a center for this large radius, and work out what this corner fillet radius is as well. Now, I have a background in education, and I taught geometrical drawing and perspective for 35 years. And one of the skills that we taught students was to draw on a drawing board with an old timber drawing board, roughly A2 size, and a T-square made out of plastic and wood, 2 set squares and a compass. You could draw just about anything. And one of the topics we used to teach was called interpenetration. This is where you would take 2 geometrical solids like a cylinder and a square pipe, and you would plot the intersection between those 2 geometrical shapes. You could then develop that shape, roll it out to a flat pattern, cut those materials out and roll them up or bend them up and rejoin them. And That was basically the technique that was used for making all sorts of industrial pipework and ducting and so on. And although these days you can do with CAD in about a minute what we used to be able to do in, say, an hour, those skills sometimes come in handy learning how to do that geometrically. So what I'm going to do here is I'll draw a vertical edge, and that's going to become my reference for the outside edge of the cover, and then I can put my contour gauge against that line and then map out or draw out that curve, which includes the corner fillet. So I already know how wide my cover is, so I can offset a center line and draw a center line through the paper that way, and then from there we can establish the radius of this curve. So my cover is 182 millimeters wide. It does have a little bit of draft on the edge, but for this exercise we can ignore that. So my center line is there. And what we need to do now is to calculate the center of this radius here. Now the technique for doing that is fairly straightforward. You just draw a chord on that curve. Now, a chord is a straight line that crosses the circumference in two places. If you then bisect that chord and extend the bisector, you can work out where the center is. You need to do that at least twice. But because we already have our center line here, we only need to do it once in this case. So with the trusty old compass, you take the intersection where the chord crosses the circumference, draw an arc. My paper is not quite big enough here. And then extend the intersection of those two arcs down through the center line, and that puts our center there. Now you should of course do that several times. If you have enough of that circumference, you should do it at least 2 or 3 times and then average out where this point crosses the center line. I can't do that in this case. My gauge isn't big enough, but for what we're doing this is going to be close enough. So we can now calculate that radius, and that comes out to 237. And all I need now is the radius of this fillet on the corner. I'm thinking that's radius 22. And my offset this way, remember, it was 91. So that's going to give me enough information now to be able to draw this out in CAD. Okay, well you can see here that I've created that 2D drawing that I did on paper into a two-dimensional sketch in Autodesk Inventor. So I got our width here of 91 to the center line. We've got our 237 radius for that curve on top and an 11mm fillet in the corner. This dimension here is irrelevant. I'll just put that in to make it look nice. And with Autodesk Inventor, what we can do now is to turn that into a sheet metal part. So if I finish the sketch here, you'll see that part extruded, and up the top here you'll see all the sheet metal tools, and the one that I used here was called a contour flange, and it just takes an open profile and extrudes that to whatever length you want, and it makes it the thickness that you want. If we zoom in here, you'll see that this metal has some thickness which you can set up in a set of rules. So the next step is to punch the hole through, which I want to do accurately using an air saw or something like that. Now, I've already done that, so we'll put that hole in, and that's it there. This end of course is curved. I haven't bothered drawing that because all I really want is the shape of this curve around here. Okay, now you can, with Autodesk Inventor, one of the really cool things is you can just simply fold it out into a flat pattern, and there's one tool up the top here, one button that you need to press, and it instantly turns that into your accurate full-size development of that cover. It also shows you the tangent lines and the center lines of the curves. It takes into account thicknesses, all of that stuff is done automatically in the software. So all I need to do then is create a 2D drawing of that and print that out on paper. So here is the 2D drawing. You can see that I've got the whole development drawn off to the side here, and on the sheet itself I've just simply put a cutout of that part that we're interested in. So what I can do now is print that out on paper. Now this is an A3 sheet that we're looking at here, and I've only got an A4 printer. But once again, one of the really cool things about Inventor is it doesn't care. It will tile the print onto whatever size paper you have. So we'll go ahead and print this and tape it together, get it cut out, and then we'll transfer this onto the metal cover. Okay, well here's the paper template that we've already printed and cut out, and it's going to be superimposed on the top of that cover. So I've got to work out exactly where I want this to go. I did actually put a mark on the cover before I removed this from the drill press, so I sort of roughly know where this point needs to go. So I'm going to do a little bit of marking out here with masking tape, get some center lines, get this held down, and then I can trace around that with a Sharpie, and that's going to become my cut line when I remove this top section of cover. Now remember, this shape that we're looking at here is not actually a circle. It's sort of elliptical in shape, and that takes into account the extra distance across this curve compared to the shorter distance, which becomes the true radius of the curve from its center. Now, like I said, I could have just done this with a pair of dividers. I could have just put a compass on there or a pair of dividers, worked out my radius and marked that around there. But somehow, I don't know, you just want to do it right. So let's get this all marked out and see how it looks. Alright, somehow or another I need to get an exact center on this, so how am I going to do that? Okay, that's about as close as I'm going to get. I'm just using my combination square here, or my combination set, to halve that difference. So I'm just checking it from both sides. I'll put a mark on that tape there. Check it from the other side. Okay. That looks like my center there. Alright, so I'm going to tape that template down there now, and we'll just go around and trace it out with the Sharpie. So I'm just going to continue this this line right around the back of the cover, and I was considering doing that with tape, masking tape, but you know what? This tool is much easier and more accurate. Okay, I just did a bit more messing around with that, and I've got a center line down the middle of the top now. I've got my tangent point at this end. I've got a tape line all the way around the edge, which is where I'll be cutting with the angle grinder. So that's all good. When I get this lifted up and welded back into position, it's going to look more or less like an OEM part, which is the look that I'm trying to achieve. So next step, let's start hacking into this and try and get this piece out with minimal distortion. Okay, well, here goes nothing. once again, I've left a little bit intact around the back here. I'll just slip through that when I'm finished. I just need to make sure that none of this sort of collapses on itself as I try and cut this curve, which is going to be yeah, a little bit hard, I think, with the angle grinder. It's sort of too tight a curve. So I'll give this air saw a go and see how that works out. I needed to get a spot where I could start this air saw, and I went in there with a Dremel and just slit that through so I can insert the blade into where the cut will start. So the plan is to come around both ways, either side of centre, and meet up with the parallel cuts on the edge. Now, this thing is incredibly noisy and not anywhere near as easy to use as I thought it would be. Let's give it a go. That's working. That's sort of cut through to about here. Let me get this clamped down somehow, and we'll try and finish that off. Alright, that's pretty close. Alright, well, I've got about, I don't know, 15-20 mil to go to that corner there, so I'm going to do the rest with the grinder. Alrighty, so there's my opening. So I just need to get that all cleaned up now and get the paint off it, and do that on both pieces, and then we can figure out how we're going to offset this. Okay, I'm doing the old CAD trick here. That's cardboard assisted design, and what I've done is I cut a strip of cardboard which is the height that I want all the way around this extension. What I've done is I've stuck that on the inside with some magnets, and I've gone around and checked my offsets all the way around, and I'm happy with that. And I thought it was going to be a simple matter of just making a strip of metal to that circumference and welding that on, and then attaching my lid on top of that. And yeah, it's a case of not so fast, my friends, because this is curved upwards in the middle, and I'm going to have a dirty great gap all the way around. So I need to work out the shape that has to be added onto this strip in order to meet up with that edge. So I'm going to make another template based off this shape here, and I'll join the two together. Alright, so I've marked a centre line on the template. I've got a centre line on the cardboard template attached to the top, and I've got a line here which represents the top edge of this card here. So if I match all of that up, we should get something that's close. Can't want to mark, put the tape on straight, will you? Okay, so that should be the shape that will match up with this. So I've got the opportunity here to do some cutting and grinding and filling and so on, and we'll get all of this looking neat and tidy, and then yeah, I'm going to get my mate Macca to go around and TIG weld all of this. I guess I should be able to do it. I could probably oxyacetylene weld it, which is a bit old school, but I don't own a TIG. Macca does. He's an expert. I'm not. That's the way we're going. Okay, well, it's time to take this cardboard template out now and transfer this onto the sheet metal that I'm going to use to make that part. So I'll take this out, cut off the excess, and then get it transferred onto the sheet metal. Alright, if I didn't have arms like pipe cleaners, we would have been done by now. So let me get this done off camera. We'll come back and it'll all be trimmed up, I promise. Alright, that's cleaned up, and just in case you were thinking I don't need enough Vegemite, that's nearly 1mm thick, or it is 1mm thick galvanised steel. So it's pretty heavy going even with aviation snips. Okay, we're going to get this curved now. I've got a jeweler's roll, so we're going to whack it in that and try and get that to conform to that hole. Okay, well, I've got my tangent lines marked out on here. All these hatched areas have to stay straight. Bits in between the hatched areas are going to be curved. So, let's see what happens here. Alright, well, that's not bad. That's going to spring around, and there'll be a butt joint on this edge here. Alright, might have overcooked that last bit, but that'll go. That'll be alright. Now, because I was more worried about my award-winning cinematography than concentrating on the build, I forgot that this sheet metal form that I've made here is meant to fit flush with the outside of the casing rather than lapped inside like I did with the cardboard template. So So this 10mm strip, which I faithfully reproduced on the sheet metal blank, wasn't necessary. So I've cut all of that off, and I've just done a bit of a trial fit here, and I think that's going to be okay. So what I need to do to keep the outside flush is to weld this strip on the inside. It's 20mm wide. It'll lap 10mm down below the cover and 10mm up inside to form a flange. And I'll spot weld this all the way around on both pieces, and then I'll get Macca to TIG that all the way around and TIG the cover on. So I'll go ahead and get this strap welded in here. Whew. Alright, that seems to be going okay. This is my DIY spot welder, by the way, and recently did a third upgrade on this, or at least second upgrade if you don't count the original build, and it's performing quite well on this job here. So I'll put a card up the top there if you want to check out the other playlists for this build, but you know, it's basically a microwave oven transformer, but it's handling this quite well. So I'm going to go ahead and get all this strap welded in, and then we'll put a few tacks on the cover, the actual sides, and we'll just speed things along a bit. Okay, I've got all this sort of lightly clamped in position just to check the fit, and it's all pretty good. So I'm going to leave these clamps in place and try and get some spot welds going around the outside there. One of the things about spot welding is the metal does twist and distort, and if you don't have it clamped down, it can slowly work its way away from the intended line of the joint. So the one thing I have done though is I've joined this free end together. So there's a strap on the inside, and I've spot welded down both sides, and yep, spot the mistake. I accidentally offset the strap toward the bottom instead of the top, and it interfered with the strap going around the inside of the circumference, so I had to grind that off. But don't worry, it's all going to be filled and painted when we're done. You never know, except you and me will know about it, but nobody else. Well, I've been messing around with this, and I've sort of got this top edge looking pretty much the way I want it. It's a bit gappy around there, but it's going to have to be sort of tapped and manipulated into place before we do the welds around here. I've tacked this around here with a MIG. Don't look at my welds. And in order to get this edge sort of curved, what I've done is I've gone around, I've done half of it using a little tool. We used to call these nibblers, so it's just a bit of flat stock with a saw cut in the end, and the length of the saw cut determines how much radius you're going to get on that edge. And the notion is that you just go around and just slowly work your way along the edge, bending it about 5 degrees at a time, and if you keep your bends close together, you'll end up with an approximation of a radius on that edge, or depending on the thickness of your material, you can bend that over to almost a sharp 90-degree angle. So in order to get all this so I can check it, I've just got a few magnets around the back here to position the top, and this timber spreader in here is just to keep these edges parallel. There's a little bit of distortion in this at present. So if I go around this other edge, this edge is still square, and the nibbler just slips over. Just slowly work your way around, don't try and bend too much in one go. And then just repeat that process backwards and forwards. Now I'm going to get this tigged up tomorrow, and we'll have a look at that process down at Macca's place. And hopefully all of the little discrepancies are going to get ironed out when we start to tack it all together. It's probably a bad idea to try and fit this perfectly now, because things aren't sitting square, they're not parallel, nothing's sort of aligned as it should be. So we'll sort of do it as we go. Now I've also done the same thing on the top. So on, hang on, here we go. So on this edge I've gone around with the nibbler and I've done that, bent that down at about 10 to 15 degrees, and I'll do the same around this edge, which I haven't touched yet. So check in tomorrow and we're going to see the welding process.
Here we go. Look at my new teeth.
Let's say there's no tool like an old tool. So say hello to the old tool himself.
I'm the old tool himself.
All right.
Exactly right.
So what are we doing today, Macca?
Well, what we're doing, we're going to weld this all up with a TIG on very low amperage, because we've got very thin material.
Okay.
And as he said, the old codger, being me, at 76, he's 16 years younger than me, he should learn more. I'll try to teach him something. Yeah, it would have been easy to do with all of this.
Yeah,
But anyway,
I reckon that's good.
happy with that, boss?
Yep.
That's a shot.
Is it beer o'clock yet?
No.
Can't say that on YouTube.
Oh, God, you're right. You'd erase that. Some of them you hear them swear.
I know. That Canadian bugger, that AVE, God. Well, it's the next day and I've just gone around and given that a good rub with a wire wheel. And the next step is now to grind off all these welds. Now, I don't know if you could tell, but Pete was struggling a bit with that TIG. It was just taking way too long. There was a lot of welding in this job. And at the end, he just finished off with a MIG, which worked fine. We could have probably done the whole job with the MIG in the first place. I think part of the problem was there was just too much blood in his alcohol stream. Well, it's not particularly pretty in here, but I'm not too bothered about that because this is going to get filled with body filler, and I'm going to put quite a large radius on that. So in fact, leaving it a bit rough is going to be good because that's going to give the body filler some key, something to grip to. So still a bit of work to do. I'll get some of the paint cleaned up. Okay, well that's where I'm going to leave this now. I think we've done enough for this episode. So in the next one we're going to do all the filling and preparation and painting and get it back on the machine. So thanks for watching along, and I just realised that this thing actually looks pregnant, doesn't it? Hey, it wasn't me. I was overseas the whole time. Anyway, I reckon this is a project that even the boys over at Project Binky would be impressed with.
Bollocks.